Okay, welcome back to finishing up day 11, which is cube root. So this should go pretty quick. Similar to square root, at least with the transformations. Graph kind of looks similar, except you have a little bit more going on. Nice thing is, and this is how it'll be different from square root, you can take the cube root of a negative number. And remember what cube root means? So that means it has 3 common factors in it. So to be a perfect cube, that means like 1 times 1 times 1. So 1 is a perfect cube. Square root of 1 is 1. So if we fill in our table, negative 1 times negative 1 times negative 1 gives us negative 1. So that's a perfect cube. 0 times 0 times 0, 0 is a perfect cube. It's 0. 2 is not a perfect cube. 6 is not a perfect cube. Negative 2 is not. Negative 6 is not. But 8 is, because 2 times 2 times 2 equals 8. So when you're being asked the cube root of 8, that means you're asking which factor repeats itself 3 times, and that's 2. And over here it's negative 2. So the values at anything between 1 and 8, the cube root of 2, 3, 4, 5, 6 will be 1 point something. The cube root between negative 1 and negative 8, so like negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 will also be 1 point something. So if you did take the time and plug these into your calculator, at negative 6, the cube root is negative 1.817. That's a rounded answer. At negative 2, it's negative 1.26. Positive 2, it's 1.26. And then at positive 6, it's the same, except positive, 1.817. Cube root function, I don't think it talks about it here. It is odd. And remember what an odd function looks like. So if you did go look at your graph, you have 0, 0, you have 1, 1, you have negative 1, negative 1. Our next one that's going to be on a perfect corner of the grid will be 8, 2. 1, 2, 3, 4, 5, 6, 7, 8 up here. And then negative 8, negative 2. So to be an odd function, remember it's symmetric over the origin. And you can see here, if you were to take your graph that's in the first quadrant, fold it over the y-axis and then the x, all of those points up here will match up with all of the points down here, okay? So notice here you have 1, 1. Down here you have negative 1, the opposite of up top. Here at 8, 2. Over here at negative 8, you're going to have the opposite of 2, which is negative 2. Okay, so that's what a odd function looks like. When you go through and graph these using transformations, 0, 0, that's like your starting point again. Okay, it's not going to be your starting of your domain and range, but it is like the middle of your graph. And then what you could do next is transform 1, 1 with your transformations, transform 8, 2, and then mirror these over. Okay, so you don't have to feel like you have to do all 5 of those when doing transformations. But notice here, what is the domain? All real numbers. You can take the cube root of every number because you can take the cube root of a negative. What is the range? This is going to go to negative infinity, just really slow, okay? And same thing up here. This is going to reach positive infinity, but just very slowly, okay? So that will be negative infinity to positive infinity. And that's it. That's your cube root graph. So when it says use your knowledge of transformations, again, anything inside affects the x. So if you set that x minus 3 equal to 0 and solve, you're going to have a horizontal shift of right 3. Okay, so remember you can do that 2 ways. Since the coefficient in front of x is 1, you can just do the opposite of 3 and say right 3. But the other thing you can do is always set it equal to 0 and you get x equals 3. And then remember, anything outside is vertical. So this is a vertical shift of up 2. So do we need to transform all of the points from the parent graph? No, just enough. So think about 0, 0. You're going to go, instead of starting at 0, 0, you're going to go right 1, 2, 3, up 2. This is your new starting point right there. Okay, so notice how I went right 3, up 2. So we transformed 0, 0 to that point. From there, you really don't even need to do every single point, okay? there was no vertical stretch or shrink, so really the pattern is like if you picked this up, copied it, and shifted it down. So notice you have 0, 0, your next one was 1, 1. You really could just go up 1 to the right, down 1 to the left, and that's giving you your curve, okay? And we can do that because there is no stretch or shrink. If you do want to be more specific, you can go through and shift all of our points, okay? So like your next one was 1, 1, which is right here. You're going to go right 1, 2, 3, up 2, and still gives you that same point. So notice I went right 3, up 2. Your one after that was 8, 2. So where is that? 1, 2, 3, 4, 5, 6, 7, 8. So it was here. From there, we can go right 3, 1, 2, 3, up 2. And that's your new point. So that's like the top half of the cube root graph. Okay, so remember we were at 8, 2. We just went right 3, up 2. And then we can just mirror that to the other side. So think of if you reflected it over here and then down, that's where you get this one. Okay, or you can go back to your point, -1, -1, and -8, -2. This is what we did, remember, first quarter. If there was a shift right 3, we would add 3 to your x's to get your new x's. And if there's a shift up 2, we're going to add 2 to your y's to get your new y's. And that's how you can get your other points. So like right 3 from -8 is going to put you at -5. Up 2 from -2 is going to put you at 0. So I definitely missed that point when I tried sketching it myself. So that's at -5. 1, 2, 3, 4. That's right here. And that looks a little bit better, okay? And you can get those your new points from your table and your calculator, okay? So that's it for cube roots. And yeah, all right. We finished up day 11. Have a good one.